Here we are, last section of Chapter 5, Transforming Quadratics. We talked about these transformations a little bit when we dealt with linear equations. We talked about the first two types of transformations. Today we're going to add a dilation and reflection to what we learned back when we talked about linears. So I'll review what we learned in linears, being translations or slides, and then we'll talk about dilations as well. Okay. Make sure that you're on section 5-6 because I'm going to have you cross off some of the things that are in your book and write new. Let's go to work. Transforming quadratics. Transformations are ways for us to see graphs move. Okay? You're going to be talking about transformations again in geometry. We'll be talking about them in algebra 2, heck, calculus, pre-calculus. This stuff is, I don't know, it can really make your graphing a lot easier once you grasp it. You should really like it because you're teenagers, and we all know teenagers like to manipulate things. Come on, that was funny right there. That was funny. So funny you forgot to laugh. All right. So that's what we're doing here is we're talking about manipulations or transformations. Okay, I want to start with the first two. And these are the two that we talked about about linear equations. And that's translations up or down. If we have some function and we add a constant on the outside of it. We have a function, we add some constant on the outside of it. That's going to move it up or down. Whereas if we have some function and we add or subtract something on the inside, that'll move it left or right or left. Now, this becomes important because I want you to realize that this addition or subtraction of something is on the outside of the parentheses. When we're dealing with the outside of the parentheses, I want you to think vertical. Write that down in your book right there. If it's on the outside of the parentheses, think in vertical. Okay? If it's inside parentheses, we want to think horizontal. This is very important to me for how I teach it. Okay. There's something else that's very important about horizontal. When it's inside the parentheses, it's usually opposite what you expect. And I'll explain here in a minute. It's usually opposite of what you expect. That's not what I wanted to have happen. Let's see if I can insert a page here. That was lovely. Okay, so here's my coordinate plane. And here is a nice, lovely parabola. We'll call that parabola f of x. Okay? If I take that f of x and I add 1 to it, what's going to happen? It's going to shift up 1 unit. So it would just simply move up like that. What if I took f of x and I subtracted 1 from it? What would it do? It would shift down 1 unit, and it would be right there. We're all cool with that. That's the easiest transformation there is. You take some function, and you just add something on the end, or you subtract something on the end. In all reality, this function is actually f of x equals x squared. That's also known as the parent function because it's the simplest form of a quadratic. It doesn't have anything with it. Okay, so that makes this function actually x squared plus 1. Still shifts up 1. And this one would be, anybody? X squared minus 1. But still the same shift. Are you okay with that? All right, so that's a vertical translation. It's a what? Vertical translation. What does translate mean? Slide. Write that down. Let's go back. Translate equals slide. Translate equals slide. Now, up and down was easy. Well, what happens now when I have f of x equals x plus 1 squared? Go to the left one. He says left one. How many people think right one? Raise your hand. It's okay. You see that plus and you think, well, plus would be to the right. But remember, it's inside the parenthesis. And inside the parenthesis, we are thinking horizontal. But we're also thinking, because it's inside the parenthesis, think about the parentheses as makeup. It's not what you expect. It's actually the opposite of what you expect. Okay? So it should be going left 1, and it would be over here. That makes sense? So what would this be? F of x equals x minus 2 squared. This would go to right. So it would be way over here. Is that cool? So, outside the parentheses, vertical. Everybody, put your hands together. Outside the parentheses, vertical. Inside the parentheses, horizontal. Say it. Horizontal. Vertical. Horizontal. Vertical. Okay. Yeah, you're laughing now, and I'm going to be watching you in a couple days on the test. You're going to be sitting over there going, it'll be fun, and I'll be the one laughing then. Namaste. All right. So, those we've already done. That's not the hard part. It's this next one. These next ones. I want you where it says further from the x. I want you to cross that out. Okay. This is a dilation. Does anybody know what a dilation is? Gets smaller or bigger. Like your pupil. When somebody shines a light in your eye, it gets a lot smaller. When it gets dark in the room, your eye gets a lot bigger. Okay? Your pupil does. Well, that's what happens with dilations. They either get smaller or bigger, enlarge or reduce. Okay? Now, this first one, that C, where is it at? It's on the outside. Since it's on the outside, what kind of dilation is it going to be? Horizontal or vertical? Vertical. Good. This would be vertical. Okay. All right, look at the one on the right. This is going to be, we want to cross out that closer to the y crap. It is also going to be a dilation. However, the C, and C stands for constant or number, the number is inside the parenthesis, which means what kind of dilation is it going to be? Horizontal. It's going to be horizontal. Okay? Now, when it comes to dilations, we want to think of two things. We want to think of a stretch or a shrink. We want to think of a stretch or a shrink. Put your hands together. We're talking about vertical. We're either going to have a stretch or a shrink. Which is it going to be? Well, when we're talking about vertical, if our number, the number that we're dealing with, is greater than 1, the number is greater than 1, C is greater than 1, then the function will be a stretch. The function will be a stretch. Now, that second line, if C is bigger than 1 but less than 0, what's that mean? Bigger than 1 but less than 0. Decimals or fractions. If it's a fraction or a decimal, it's going to be a shrink. Notice where I put the words. Shrink, stretch. Get it? Cool. So at this time, I'm going to use Desmos to show you this. Because I think this is the easiest way to see it. F of x is the same thing as y, right? So y equals x squared. Everybody watching? Watch it very carefully. You ready? What happened? All right, watch what I'm doing. I'm adding a 2, taking it out. Adding a 2, taking it out. Adding a 2, taking it out. Now, I don't want you to talk about smaller or bigger. What I want you to think about is we're talking about this. There's no parentheses right there, right? So it's on the outside. And so since it's on the outside, we're talking about vertical. What am I doing to that parabola? I'm grabbing it and I'm stretching it. Watch it stretch. Ready? See me stretch it? Let's do it again. I'll use a 4 this time. You'll see a big stretch. Are you ready? Watch right now.
Wait, that's a shrink.
That's a stretch. Look, it's very important. We're talking about vertical, right? Put your hands together. If I take this rubber band, okay? If I take, oh, that one broke. If I take this rubber band, creates a parabola, right? Watch what happens when I stretch it. It gets skinnier, doesn't it?
Yeah.
Okay, so it gets skinnier. What happens if I take this and I stretch or shrink it? It gets fatter. Do you understand? Watch what happens when I give you a fraction. If I put a fraction, it shrunk. Okay? But so I want you to imagine in your head, because this is difficult. This dilation stuff can be very difficult. And that's why I'm being intentional about talking about vertical and horizontal and talking about a stretch and a shrink. Because I want you to think about what would happen to a parabola if I actually grabbed it and stretched it. It would become skinnier, right? What happened if I grabbed a parabola and I shrunk it? It'd be like a marshmallow when I put it between my s'more crackers, right? It would just it'd get fatter. Okay, snore crackers, s'more crackers. All right. Any question on the vertical dilation of a stretch or a shrink? It's clear as mud? Okay. Let's go to horizontal. What have we already learned about horizontal? Well, we've already learned that it's inside the parentheses, and it's not what we expect, right? So if it is C is greater than 1, what would we initially think? If it's greater than 1, we would initially think that's going to be a stretch. But it's a shrink. And if it's a fraction, it's a stretch. Because it's inside the parentheses, and those parentheses make it do the opposite of what we expect it to. Okay? Let me go back to Desmos and give you an idea. Had to put the parentheses in here. Ready? Are you watching? 1, 2, 3.
Oh my gosh. I mean, we got thinner.
Now think about it. We're talking about horizontal now, right? So since it's greater than 2 or greater than 1, it's going to be a shrink. What happens if I take a parabola and I shrink it this way? It gets skinnier. See, we don't talk about fat and skinny either. We're talking about a stretch and a shrink. So watch what happens if I make this thing a fraction. It's a stretch. So think about me grabbing a parabola and stretching it horizontally. Does that make sense? Stretch and shrink, stretch and shrink. Cool? All right, last thing. Last thing I want to give you today. Okay? And that's back to these transformations. And it's not in your notes anywhere. Okay? So I need you to write this down. I don't think it's in there anywhere. And that it goes along with the dilations in the same place as the dilation. And that is a negative equals a reflection. Negative equals a reflection. What's that? Negative sign equals reflection. So f of x equals negative x squared. Which way is this going to reflect? Horizontally or vertically? It's going to be vertical. Why? Because it's not inside the parentheses. How about this one? F of x equals negative x squared. How is it going to reflect? Horizontally. Now, when I say they reflect, they are reflection over the axis. And I'm just going to leave it as axis. Okay? And stay with me here. If it's going to be vertical, here's my parabola. See my parabola? It's my fingers up in the air. If I reflect it vertically, what's it going to do? Like this. Yes? Vertical. Yeah. I am Iron Man. Oh, sorry. Vertically. What happens if it reflects horizontally? It goes this way. Now, stay with me. Stay with me. Let's go here. This one would be hard to see the reflection. That first one, because it was like But let's say this is my original function. If I'm going to reflect it vertically, it would look like this. Yes. But if I were to reflect it horizontally, it would look like this. Why? Because it reflects around the axis. Reflects around the axis. Okay? Always. Whew. Mind blown? You did learn some of this last year? Excellent. Excellent. Here's what I want you to do. I want you to do 5.6. 5.6 evens. 5.6 evens. What do you do after you do the evens? Check the video. All right. Have a great day.